All right, in this video, we're going to look at this entire traverse and find all of the interior angles. So we're going to start up here with angle FAB and figure out what angle is formed at FAB. And so see what information we know here. We're given bearing information. So this first information is the bearing as we go from A to B, and that is north 73 degrees, 21 minutes east. So we can go ahead and put our orientation on here. So we have our north, south, west, east at A, and this bearing shows that this measurement that we're given here is coming down from the north and telling us that it's 73 degrees 21 minutes, that angle measurement. And then we're also told information for this bearing, that's line F to A, and that's going to be north 14 degrees 29 minutes to the west. So we'll go ahead and put our north, south, east, west at point F and see what measurement that is. And this one's coming from the north and going to the west, so that's giving me this angle measurement here. Coming from the north and going to the west is 14 degrees, 29 minutes. So if we are looking for this angle in here, we're going to have to figure out um, from 180 what we need to subtract. So we'll need to subtract this amount, that 73 degrees, and then we'll also have to subtract this interior amount here. But if we remember our rule about rectangles here, we have those alternate interior adjacent angles. So if we know that this measurement off of this north line is 14 degrees, 29 minutes, that is the same measurement of this angle off of this straight line here. So in order to find that angle FAB, our first one here, put that up here, we can just take that 180 degrees and subtract those two bearings. So minus 73 degrees, 21 minutes, and minus this 14 degrees, 29 minutes. All right, we'll have to borrow from this degree here. We'll make that 179 degrees and 60 minutes and subtract the 21 and 29. That gets us down to 10 minutes. And then 179 minus 73 minus 14 gets us down to 92 degrees. So my uh, interior angle for FAB is 92 degrees, 10 minutes. And then we'll keep moving along the traverse here and we'll go to ABC. So that's my angle formed here, ABC. So let's take a look at what bearing information we know here. I'll go ahead and draw my coordinate grid here. All right, so we know that this bearing line BC is coming from the south going to the east and has that measurement of 86 degrees, 14 minutes. Our angle of interest also has another component to it. It also has this piece as well. That's going to be part of that. So we'll go ahead and take that 86 degrees and 14 minutes, and we can add that to this 73 degrees, 21 minutes, because again, if I complete my rectangle here, this angle formed here and this angle here are alternate adjacent angles. And so for that ABC, I'm going to add that 86 degrees, 14 minutes, and the 73 degrees, 21 minutes. And that gets me to 159 degrees and 35 minutes. And there are other approaches you can take to this, looking at forward and back azimuths and doing computation that way. But I'm just kind of trying to, kind of use some angle reasoning and put that together that way. All right, let's go to the next one here. We've got BCD. So we're coming around here to find this angle BCD. Again, we know that bearing information from line BC, and now we've got new information here for line CD. So let's get a picture of what we know and what we don't know at this angle of interest. We do know this bearing is coming from the south going to the east, so we know this bit of that angle. So what we're missing is this piece in here. So we can see that part of this piece is a 90-degree angle, right? So there's that 19 and 19 degree 21 minute. There's a 90-degree angle, and then there's a small piece in here as well. Okay, that is not the alternate adjacent angle of this 86, 14. That's actually 90 minus this 86, 14. So let's go ahead and figure out what that is. So we'll put that together for BCD. I'll put that over here. My first thing I'm going to do is figure out that tiny angle by taking 90 degrees and subtracting 86 degrees 14 minutes from that. So I have to make that 89 degrees, 60 minutes. And that's going to give me 46 minutes and 3 degrees. So now I'll sum up what I've got here. I've got that little 3 degrees, 46 minutes. I've got 90 degrees, and I've got that 19 degrees, 21 minutes. Put 0 minutes there as a placeholder. So I add those all up and I get 113 degrees and 7 minutes. So I'll get that 6 here and I'll roll that over there so I have an extra degree. So I didn't put the other one in there. 113 degrees, 7 minutes, and this one was 159 degrees, 35 minutes. Okay, let's go on to CDE. So coming back around here, I'm looking for this angle measurement in here. So now I'll look at D and see what bearing information I have as I go from D to E. And as I go from D to E, I have this information coming from the south to the west. So that's this angle in here that I know. This angle is what I'm looking for. And then I have information from that last bearing of that angle there. So that will tell me this information in here. So in order to find that CDE, I'm going to go ahead, put that here, and take this 44 degrees, 57 minutes, and subtract that from 90, right? If I came all the way up here, I would be at 90 degrees. So I'm going to subtract that so I can get this first part there. So I'll start with 90 degrees minus the 44 degrees, 57 minutes. We'll make that 89 degrees and 60. And so that's going to become 45 degrees and 3 minutes. And then we're going to have to add that to this part of the angle, which is going to be 90 degrees minus this 19 degrees and 21 minutes. So I've got another part that I've got to subtract here. 90 degrees minus 19 degrees, 21 minutes. Again, I'll borrow 89 degrees, 60. So that will become 39 minutes and 70 degrees. And now I can take these two and add them together to get that angle CDE. So 45 degrees, 3 minutes, and 70 degrees, 39 minutes is going to give me a total CDE angle of 115 degrees and 42 minutes. All right, a little tricky on that one because you have to, neither of those bearings as reported will give you the information you need. You have to find the 90 degrees minus each of them and then add them together. All right, on to angle E. Come over here. So let's go ahead and put our north, south, west, east lines here and take a look at this bearing information that we're given here. And this one's coming from the north, 23 degrees, 19 minutes towards the west. So that's the information that I have of this angle, but I also need this part of the angle to get all of E. So I'll take that 23 degrees, 19 minutes west, and then if I complete that rectangle, I can see that these are alternate interior angles, so I'll add that to that 44 degrees, 57 minutes. So that one's a little bit more straightforward for DEF. Take the 23 degrees, 19 minutes, and add it to the 44 degrees, 57 minutes. And we're going to have to carry that. So I'll get a 6 there, and then that will become a 1, and then we'll get 68 degrees. So 68 degrees, 16 minutes for that DEF. And then last one here coming around the bend, EFA. It's putting together a bunch of angles to figure out what that is. We've got that 14 degrees, 29 minutes. And then we have, as part of this, you can see there's a right angle in there. So we've got a 90 degree. And then we have this little piece of this angle, which is not the alternate interior of this. So we're going to have to take a 90 minus that 2319 to figure all that out. So let's do that first for EFA. I'll put that at the bottom here. I'm going to start off by figuring that piece of an angle by taking 90 degrees and subtracting 23 degrees, 19 minutes. 89 and 60. And so that becomes 41 minutes, 66 degrees. And then I'll add that to the 90. That's in the middle there. And then I'll add that to that little piece from that other bearing, that 14 degrees, 29 minutes. Put a 0 there just to hold the place. And when I add those all together, again, I'm going to have to carry that 6 into the next. So that's going to become 0, 1, and then this will become 171 degrees. So 171 degrees and 10 minutes for that last EFA.